Hello, my dear students. Students, now we are going to discuss the another most important question: derivation of the gas laws from kinetic gas equation. Boyle's law and Charles law. How can we derive the Boyle's law and Charles law from kinetic gas equation? It carries 4 marks. Okay. According to the Boyle's law we can define as at constant temperature, the volume of a given mass of a gas is inversely proportional to its pressure. Right? This is Boyle's law. Now let us see. Derive the Boyle's law from kinetic gas equation. First of all, what is the kinetic gas equation? Let us see. The kinetic gas equation is kinetic gas equation. PV equals to 1 by 3 mn u square RMS. This is the kinetic gas equation. Right? This is the kinetic gas equation. Can I write PV equals to 2 by 3 into 1 by 2 mn u square RMS, multiplying with numerator and denominator with the same number 2. Multiply with 2 and divide with 2. With the result, the value will not change. See 1 by 3 mn u square RMS. Then PV equals to, can I write 2 by 3 equal into, here 1 by 2 mn u square, can I write Ke? Since kinetic energy of the gas molecules is equals to 1 by 2 mn u square RMS. Right? According to the kinetic theory of gas molecules, according to kinetic theory of gas molecules, kinetic theory of gas molecules, according to kinetic theory of gas molecules, kinetic energy or average kinetic energy is directly proportional to absolute temperature. Average kinetic energy is directly proportional to absolute temperature. Therefore, K equals to, remove the proportionality, then we can represent with constant term, that is K. K equals to Kt. Let us consider it is the equation 1 and this is equation 2. From 1 and 2, from the equation 1 and 2, we can represent as PV equals to 2 by 3. Here instead of Ke replace with Kt. PV equals to 2 by 3 Kt. Right? See, Boyle's law defined that at constant temperature, here T is a constant, K is a constant term, 2 by 3 value also constant. That means 2 by 3 constant, K constant and T constant. That means PV equals to constant. So this is the Boyle's law. PV equals to constant. Otherwise, you can represent the V or V equals to constant by P. Remove the constant term, V proportional to 1 by P. So this is the Boyle's law. Okay, students. First of all, remember the kinetic gas equation. PV equals to 1 by 3 mn u square RMS. PV equals to 1 by 3 mn u square RMS. Okay. Just you have to multiply with same number 2 and divide with 2. We get the value will not change. So 1 by 3 mn u square RMS. 2 by 3 into 1 by 2 mn u square RMS. We know that the kinetic energy equals to 1 by 2 mn u square. That's the reason why 2 by 3 instead of 1 by 2 mn u square RMS, can I write Ke? Kinetic energy, according to kinetic theory of gas molecules, kinetic energy is directly proportional to absolute temperature. Remove the proportionality and add constant term K. K equals to Kt. Here instead of Ke, you have to substitute the value K equals to Kt. 2 by 3 Kt. PV equals to 2 by 3 Kt. In this, T is a constant because at constant temperature, right? Boyle's law defined that at constant temperature, the volume of a given mass of a gas is inversely proportional to its pressure. So T is a constant, K is a constant term, 2 by 3 value also constant, PV equal to constant or V proportional to 1 by P. This is the Boyle's law. Next, similarly Charles law. How can you derive the Charles law from the kinetic gas equation. These steps are all are same. Here in the last step you can change the, instead of PV, just you have to write V equals to 2 by 3 kT by P. Right? Kinetic gas equation is, kinetic gas equation is PV equals to 1 by 3 Mn U square RMS. So this is the kinetic gas equation, right? Next, according to Charles law. So what is Charles law? At constant pressure, the volume of a given mass of gas is directly proportional to temperature. So PV equals to 2 by 3 into 1 by 2 Mn U square RMS. Okay. Then PV equals to 2 by 3 into KE. Since KE equals to 1 by 2 Mn U square RMS. So these are the same steps. Okay. Let us consider it is the equation 1. Then according to kinetic theory of gas molecules, kinetic theory of gas molecules, PV, sorry, KE proportional to absolute temperature. Therefore, KE equals to, you can represent the constant term KT. Let us consider this equation 2. From 1 and 2, from equation 1 and 2, from the equation 1 and 2, PV equals to 2 by 3. Instead of KE, can I represent KT? 2 by 3 KT. Right? What is Charles law at constant pressure? That means, can I represent like this one? V equals to 2 by 3 KT by P. Here P is a constant term. P is a constant term. 2 by 3 value also constant. K also constant. So these are constant. Then can I represent the constant into T? Remove the constant. That means V proportional to T at a constant pressure. So this is the Charles law. These are same steps. Just in the last step, just you have to represent the, instead of V in Boyle's law, just you have to write P in the denominator. Here PV equals to constant. This is the Boyle's law. PV equals to constant is the Boyle's law. Here V proportional to T, or V equal to constant T, V equal to KT, right? That is the Charles law. Okay, students. This is Boyle's law and Charles law. Thank you, students.